Hello everyone, my name is Nikhita and I'm currently pursuing the Executive PG program in Data Science and AI from IIITB with a specialization in data analytics. Today I'll be walking you through a Python lab assignment, finding two elements whose sum is closest to zero. The agenda is to understand the problem statement and then we'll be going through two approaches, brute force and optimized, then Python implementation and explanation, followed by conclusion and key takeaways. Problem statement. The task is simple but interesting. You're given a list of integers, both positive and negative. Your goal is to find two elements whose sum is closest to zero. So let us consider an example with the input given in the list -476 to n minus 5. So the output that is expected is -5, 6 because the sum is 1, which is closest to 0. Understanding the problem. Here are a few key observations. We care about the absolute value of the sum, not whether it's positive or negative. The list may have positive, negative, or mixed integers. We need the pair with the smallest absolute sum. Here is the naive approach, which is also known as brute force approach. In this, we check every possible pair. Then we calculate the sum and take its absolute value. Then we track the pair with the minimum absolute sum. This is easy to implement but has a time complexity of order of n square. It is not efficient for the large data sets. Then we come here is the optimized approach, which is also known as two-pointer technique, which is a better method. In this, we first sort the array, and the second step is to use two pointers, one at the start, one at the end. And then we calculate the sum of two elements. If the sum is less than 0, we move the left pointer to the right, and if it is greater than 0, we move the right pointer to the left. We keep track of the pair with the closest sum to 0. This approach runs in order of n log n due to sorting and order of n for the scan. Here is the pseudocode. Let me explain the logic step by step. As we have seen in the previous slide, we are first gonna define a function. Then we're gonna sort the array. Then we're gonna use two pointers. And then we calculate the sum of these two elements. If it is less than 0, we move the pointer to the right, and if it's greater than 0, we move the pointer to the left. This logic ensures efficiency by combining sorting and the two-pointer scan. The data structure and edge cases. Data structure used are a list or an array to sort the input integers. A tuple is used to store the resulting pair. Edge cases to consider. Input with all positive or negative integers. Any list less than two elements will be considered as an invalid input. Multiple pairs having the same absolute sum and a very large list. Our solution still scales very well for very large lists as well. Evaluating efficiency. Let's evaluate the time complexity. Sorting, it is of the order n log n. For two-pointer traversal, the time complexity is of the order n. So in total, it's of the order n log n. The space complexity, since we sort the list in place, the space complexity is of the order 1. This makes our solution highly efficient and scalable, even for the larger data sets. Now let's look at the final Python code. In this, we are first going to define a function, find closest to the 0 pair, and then we sort the array first. We then initialize 2 pointers, left at the start, right at the end. We use a while loop to keep narrowing the search space. If the current sum is closer to 0 than a previous best, we update the closest sum and the pair. Depending on whether the sum is negative or positive, we move the left or right pointer accordingly. Finally, we return the best pair found. Let us look at sample inputs and outputs. If the input is -4, 7, 6, 2 and -5, when we give the function find closest to 0 pair, then we're going to get the result as -5, 6. This result is the closest to 0 in that given array. If the input is as shown below, -50, 34, -19, 24, 33, 10, -46 and -38, then the answer is going to be -38, 34. As expected, it returns the correct pair with the sum closest to 0. To summarize, we use sorting and 2 pointers to design an efficient solution. The algorithm handles edge cases and large inputs well. It's faster and more scalable than brute force approach. Thank you for watching. If you have any questions, feel free to reach out to me. Thank you.